Good evening, everybody, and welcome back to revision session, grade 12, paper 1. Well, this night I decided to discuss functions, previous paper, functions, functions and inverse, parabolic functions. We also have a little bit of a cubic function there. So we're gonna do these three questions. It's question 4, question 6, and question 9. They are all from a previous paper from Limpopo 2022. It's prelim question paper. So I figured that this question are nice, so they will help you to revise functions for your paper on Friday there. Now let us start. So question 4, it says the figure below shows the graphs of f of x equivalent to negative negative into x plus 7 all to the power of 2 plus 25, and g of x, it is equivalent to x plus 2. Mn, it's parallel to y-axis. A and B are the x-intercept of what? I think of the function f. They meant the function of what? The function of f there. So this is for the function of f. So P is the turning point of f. We can see that. P is the turning point of the function f. Points A and C lie on both graphs. Point A and C, which are these ones, C, and that's your A there. They both lie on our functions. So D and E are the y-intercept of the graphs. So we see that we have our E here, and we also have our D there. So yeah, those are our y-intercept there. Now let us start with the first question. The first question, it says, determine the coordinates of point P, the turning point of the parabola. The turning point of the parabola there. So I'm gonna do this question with three methods. I'm gonna use three methods to solve this question. We will start by solving this using inspection method, which is the definition of the turning point. Then the other one is by using the formula. Then the other one is by using differential calculus. So please, when you use these methods, please check your mark allocation. Your mark allocation is 2 marks, meaning you will have to use a shorter method, which is inspection for this case. But I'm going to show you 3 methods so that when you encounter the same problem as this one, you know that you have at least 3 methods to solve the turning point of a parabolic function. Now let us start. We have f of x equivalent to negative into x plus 7 to the power of 2 plus 25 there. Okay, so our solution goes like this. We're gonna say by definition, sorry about that, so it should be definition. So by definition, we know that a turning point of graph f, it is same as saying negative p is to q. But now where can we get negative p and q? If we consider the standard equation of our turning point formula there, if we write this function in a turning point form, it's going to be a into x plus p to the power of 2 plus q, meaning the turning point of this function f it is just negative p is to q. So now for this case, we see that we have 7. So that means the turning point of our graph then should be what? It should be the turning point of f for this case. It should be negative 7 there. And our q is just 25. So that means the point P, it follows negative 7 is to 25 there. It follows that it is negative 7 is to 25 there. So your mark allocation for this one is just 2 marks. You'll get 2 marks for that. All right, you'll get 2 marks for that. So let us suppose that you were given the same problem, but you were required to use another method, because it's easier if you have like many methods to solve problems, like so it's easier that way if you have a lot of methods to solve a particular problem. So now let us check if we had let me do this. Let us check if you had the same problem, but we wanted to use another method. All right, let us say you wanted to use another method there. Let's say you wanted to use another method. So we were gonna do this. So let's say method 2. Now let us consider method 2. Now for method 2, we're gonna use the definition of the tangent. But the first step that we'll apply, we will say set our function f of x to be equivalent to negative x plus 7 to the power of 2 plus 25 there. Now you will want to expand this function. All right, you keep that negative outside, then you square the first, you multiply x by 7 by 2. That's how much? That's 14x. Then you square the last term, which is 7 squared, which is 49, then plus 25 there. So plus 25 there. So if we proceed, we will distribute this negative. We will have negative x squared minus 14x minus 49 plus 25. Now simplifying further, if we simplify further, we will have negative x squared minus 14x negative 49 plus 25. So I get minus 24 there. I get minus 24 there. So now if I proceed, I will just say my function f is negative x squared minus 14x plus 24. So I'm gonna write by definition, I know that my turning point, it is defined as negative b over 2a is to 4ac minus b squared over 4a. So this is the definition of your tangent there. It's negative b over 2a is to 4ac minus b squared over 4a. So now this is your a, this is your b, and that's your c there. Now when you apply this, you will have, what is your b? It's negative 14 over 2. What is your a? Negative 1 is 2. 4. What is your a? Negative 1. What is your c? Negative 24. And what is your b there? It's negative 14 all to the power of 2. This is all over how much? This is all over 4. What is your A? Your A, it is minus 1. Your A, it is minus 1. Your A, it is minus 1 there. So now, when we use our calculator, we see that negative times negative is how much? It's positive. So we have 14 as our numerator divided by negative 2. So that's 14 divided by negative 2. It gives you how much? It gives you negative 7 there. Okay? Now it gives you negative 7 there. Now let us check. We have negative 4 times negative 1. That's negative 4. Then negative 4 times negative 24. That's just positive 96. So we have positive 96. All right. We have positive 96 there. We have positive 96. So that's positive 96 on top. Sorry, let me change the color. That's positive 96. Then minus. So we see that negative 14 to the power of 2 is just 196 divided by 4 times negative 1. That's negative 4 there. All right, that's negative 4 there. So now as we proceed, I see that we have negative 7 here. We agree. So 96 minus 196 is just minus 100 divided by minus 4. So it is clear that this is minus 7 is 2. Negative 100 divided by 4, that's just 25 there. So you get the same solution, but this is longer. All right, this is longer, but it is also a possible method that you can use to solve that problem. All right, so you will just be awarded 2 marks for your turning points there. But this one you take an extra mile. This one you take an extra mile. It is quite tricky because you need to commit this formula to memory. So you need to commit this formula to memory because you're not given this formula. You need to know it by heart. So that is why I consider this method as tricky, but you may use it if you like. You may use it if you like. Let us check another one. Let us check another method. Another method, which is method 3. Let me use this color. Let me use this color. Method 3. For method 3, you can use differential calculus. All right, you can just use differential calculus there. You can just use differential calculus. You can say at f prime of x, we know that we have a 0 because that's our maximum, our minimum. So now we have f prime of x to be equivalent to, this is a polynomial function. We differentiate each term individually. So I'm gonna have minus 2x, all right, and minus 14 there, and minus 14 there, and minus 14 there. So now we know that at a turning point, yeah, which is our turning point, we know at the turning point this must be 0. So it's negative 2x minus 14. We take that negative 14 that side, it will be 14 equivalent to negative 2x. This is just negative 7 there. Now we take this negative 7 and substitute to the original equation. We substitute this to the original equation to get negative 7 to the power of 2 minus 14 into negative 7, and what? Minus 24 there. Minus 24 there. That's minus 24 there. Are we happy, guys? Can I get a thumbs up for this? Can I get a thumbs up for this? Are we happy? I'm sure you have paused the video to try out this question, and you are happy with this question. Please make sure you pause the video and you do this question. And remember our rule. We rewrite, we redo, and review rigorously. All right? That means we need to redo these questions. We need to redo these questions. Make sure that when you get them wrong, you redo them. All right? So now let us check. We have negative, so negative 7 to the power of 2, it is just 49 there. All right? Then we have negative 14 times negative 7, which is positive 98 minus 24. This is positive what? 98 minus 24 there. So if we minus, this is negative 49 plus 98 minus 24, it is just 25. We have 25 here. So now that means your turning point, or the point P, is just negative 7 is to 25. So as you can see that for just 2 marks, you can have 3 methods, okay? You can have 3 methods, but you need to make a choice, all right? You need to make a choice that which method works better. I think the first one works better because it is just inspection, because it's 2 marks. So you need to know the definition of turning point, that when you are given your function in the standard form, the standard of turning point form, the turning point form, so to speak, it is just negative P is to Q, your turning points there. Happiness. Now, let us go to 4.1.2. You want to find the length of, we want to find the length of DE there. All right. We want to find the length of DE there. How can we find the length of DE? How can we find the length of DE there? The first step, we need to consider that G cuts our y-axis at point D. That means at D, x, it is 0. It means that y should be 0 plus 2. So that means our y here, it is just 2. The coordinate of point D, it is 0 is to 2. I think we agree that we have 0 is to 2 here. What about E? So I will say at E, we know that x must be 0. So f of 0, it is just 25. F of 0, it is just not 25. I'm lying. It cannot be 25, all right? It cannot be 25 because this is wrong. Let me do this. Let me get a space for that question. Sorry. Let me get the space for that question. Now, we see that I'm going to write out this question nicer. Let me say 4.1.2. We see that at E, we set x to be 0, so that we will have y is equals to 0 plus 2, which is 2. So this implies that the coordinate of D is 0 is to 2. Now at D, we set x to be 0. So that's f of 0 equivalent to negative 0 plus 7 to the power of 2 plus 25. So this is negative 49 plus 25. That's negative 49 plus what? Plus 25 there. I hope you get this question, all right? I hope you get the feeling of this question and how we will go about this question. So now we just get negative 24 for this one. Just get negative 24 for that one. Now let us check. Let us check. We wanted to find the length, so we know that the coordinate of this point is just 0 it is to 0 is to sorry 0 is to negative 24. 0 is to negative 24 there. 0 is to negative 24 there. Now the length of DE. The length of DE. We're gonna be smart about it. Let us just write D and E. I'm gonna show you how you can construct this. This is your D and that's your E. If you take it like so. If you take it like so. Sorry. This is your D and that's your E there. Oh shit. Yes. So this is your D. Sorry. This is your D and that's your E. So for D, we have, according to this one, we have what? For D, we have 0 is to negative what? Let me check. 0 is to 2, not negative. So we have 0 is to 2. And for this one, we have 0 is to negative 24. I'm going to use distance formula. I'm going to say D squared, DE squared is equals to x1 minus x2 all squared plus y1 minus y2 all squared. So let us name this one x1. Let us name this one x2. Let us name this one. Sorry, this is x1. I am making a lot of mistakes today. So this is x1. This is y1. This is x2. This is y2 there. All right. So now if you proceed with this one, I'm gonna say my x1 it is 0. Then my x2 it is just 0 again. So plus my y1 is 2. My y2 it is minus 24 all squared. So DE squared it is equals to 26 to the power of 2. So if you put the square root both sides, we see that our DE it is just 26 units. It is just 26 units there. It is just 26 units there. So that's how you get your 2 marks for 1.4 point what? For 1.4 for 4.1.2, sorry. So this is just 2 marks for this one. But now this method again it is longer. All right, especially this part whereby you use your distance formula. You can just use the definition of the above function and the below function. All right, let us just do some quick recap. Let's say you have a graph of this form. Okay, I'm just gonna draw a rough sketch. Now let's say you have a cubic function and you have a straight line of that sort. Now let's say this point and that point. You have your A, then you have your B. And that point there, that's your A, that's your B. So we are focused on this area there. Now you want to find the length of this function, or no, of AB. So let's just name our functions. Let's say this is your F, then this is your G. So the length of AB. You will find the length of AB by doing this. The length of AB, it will be the above function minus the below function. The above function, which function is above? From this point, let me show you. And let me use this one. If you focus only on this region, we see that function g, it is above function f from x1 to x2. So meaning the length of AB will be, let me call it L of x, will be what? It will be the above function, which is what? What is our above function? It's just g of x minus the below function f of x. All right. So this is how you can find the length. You need to check the above function and you must minus that above function with the below function. That's how you get the length. Now, for this case, we see that here we have 2, there we have 24. So which one is your above function? We want to find the length of DE. Let's say length, which is equals to DE. It is just above function, that point. So it's 2 minus the below function. So that's 2 minus the below function, which is 24. So your answer, it is 26 units using that definition. Your answer is just 26 units. So sorry about that. So this is 2 marks. So that means you need to consider this kind of method. Okay, you need to consider this kind of methods. You need to understand your definitions. If you understand your definitions and theorems, you can just deduce that the answer is blah 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 because you understand the definition. All right, you won't use the longer methods which will take your time. So now method 2, we can just say L is equals to D E, which is equals to the above function minus the below function. We get 26 units there. You get what? 26 units. So that's how you do it. All right. If you understand your definition, that's how you do it. That's the reason why we are teaching you math. We are teaching you how to think, and you need to think faster. All right. We are training you on how to think and to think faster. All right. So I hope you understand that these methods are there to help you to complete your exam. So now let us continue. Let us continue and do 4.1.3. Let us continue and do what? 4.1.3. 4.1.3, they say determine the coordinates of C. Determine the coordinates of C. Let us check our function first. Let us check our function first. Where's C? This is your C. All right. So now we see that point C, coincidentally, point C, let's say at C, f of x, it is equals to g of x. We call that a shared point. All right, f of x is equals to g of x at that point. Now what is f of x? We know that f of x, it is minus x squared minus 14x minus 24, and we know that g of x, it is just x plus 2. Now let us simplify this further. This is 4.1.3. Sorry, this is 4.1.3. So now we will take this x that side, so that's minus x. That's minus x squared minus 15x. So that's negative 24 minus 2, that's minus 26. is equals to 0 there. Now we can divide by negative. We can divide by negative to have x squared plus 15x plus 26, which is equivalent to 0. We can factorize. So we want factors of 26. When we multiply them, they give us how much? Sorry, they give us 26. But when you add or subtract them, they give you 15. So now for this case, you'll add them. So I think it's just 13 and 2, because 13 times 2, it is 26, but 13 plus 2, it's 15. So it will be positive, and that's positive. It is equals to naught there. So you have x plus 13 equals to 0, or x plus 2 is equals to 0. So your x is minus 13, or your x is minus 2. So now let us make our choice. Let us go back to our graph. Let us make our choice. So now it is clear that our negative 2 will be here. Our negative 2 will be there. Then our negative 13 is just there. All right. So that means our x value for C, it is just negative 13. So now for you to find the corresponding y value, you can just substitute this. So we won't take this one. We will just say f of negative 13, it is equals to, what? And when you insert your 13 there, sorry, I think I'm gonna use g of x. It's easier that way. So I'm gonna say g of x negative 13. So I'm gonna say negative 13 plus 2. So that's 2 minus 13, which is minus 11. So now my coordinate of C is just negative 13 is to negative 11. So that's negative 13 is to negative 11. So let us check our mark allocation. We're gonna give you a mark for this. I'm gonna give you a mark for this, for knowing that at point C, f of x, it is equals to g of x. I'm also gonna give you a mark for simplification. I'm gonna give you a mark for the standard form. Also a mark for your factors there. Also a mark for your factors. I'm gonna give you a mark for the values of x, both of them, and I'm gonna give you a mark for the value of c. So you, in total, you get 2, 4, 6. So you get 6 marks. So you get 6 marks for that question. So that question is 6 marks. All right. I hope you are happy with this question. Please let us move to 4.2. Let us move to 4.2 there. Let us move to 4.2. 4.2. 4.2. So now the question says, the question it says, the graph of G is shifted up to pass at B. Determine the equation of the shifted graph of G. Determine the equation of the shifted graph of what? The graph of G. Now let us check. So our graph of what? Of G, it is shifted in such a way that it passes at what? At B. So if I make my rough sketch, this graph must pass here according to this question. So it must pass at what? At B there. All right. Already we know that our gradient for G and our new graph will be the same, because these two lines, they seem to be parallel. Actually, they are parallel. But now, this must pass through B. All right? This must pass through B. Do we have coordinates of B? Do we have coordinates of B? Yes, we can find coordinates of B. Okay? We can find coordinates of B. So, we're gonna say since, sorry, let me use another color. Let me uh, so now let us call that function that is shifted up h. So I'm gonna say since h is parallel to g, then the gradient of h is equals to 1. Now at b, what is it that we know? We have f of x equivalent to negative x squared minus 2, minus 14x minus 24. Now we can simplify this further to have those x values. All right, we can have those x values. So now I can divide through by negative, so I'm going to have x squared plus 14x plus 24. So which factors am I going to use? I'm going to use 12 and 2. So I'm going to have what? I'm going to have x plus 12 and x plus 2, which is my f of x. So now we set f of x to be naught to show that 0 it is equals to x plus 12 x plus 2. So my x is equals to minus 12 or x it is minus 2. So now we will make a choice by checking our sketch. So it's negative 12 and negative 2. Now let us check where is our negative 12 and where is our negative 2. So it is clear that our negative 2 is here. All right, we have already found negative 2 at A. So that means our B should be negative 12, as we have negative 13 here, so it makes sense. So now that means the point B, it is just 0 is to it is just negative 12 is to 0 there. So when B it is just, we know that B it is just negative 12 is to 0. So now using B, we have y is equals to x plus c, because already the gradient of that new function is just 1 because they're both parallel to g. So now this is your y, this is your x, this is your y. So I'm gonna say 0 equivalent to negative 12 plus c. So therefore my c is just 12. So that means the equation that we're looking for, it's y is equals to x plus 12 there. It's just x plus 12 there. I hope everyone is happy with this question. Let us check our mark allocation. How will we mark this question? I'm going to give you a mark for what? I'm going to give you a mark for this. All right. I'm going to give you a mark for this. I'm also going to give you a mark for your factors there and the values of x. I'm also going to give you a mark for noticing that these two lines are parallel and they share the same gradient. So that's 3 marks. 1 mark for that and 1 mark for your final answer there. So that's actually 5 marks. That's just 5 marks. That's 5 marks there. All right. Now, our last question for this video, 4.3. Determine the values of x for which the length of Mn is at a maximum in the domain where f it is greater than g. In the domain whereby f it is greater than g. What is the meaning of this? What is the meaning of this? They basically mean that f is above g. So that means the way I see it, the length of Mn will be the above function minus the below function. Now let us check. If we go back here, we want what? Mn. All right, the length of Mn. So that will be the above function, which is your f, then your below function is g. So it is just from this point, it's just from this point to that point there. So this is just this region here, this one. That's where f it is greater than g. That's where f it is greater than g. Now let us do it. It's nice. Let us do it. It's just in a nice question there. Let us do it. So to find the length of Mn, I'm gonna say set L of x to be equals to, set Mn to be equivalent to f of x minus g of x, which is equals to L of x. Okay, so now this implies that L of x is equals to the above function, which is negative x plus 7 to the power of 2 plus 25 minus the below function. Which one is our below function? Let us check our below function. Let us check our below function. Our below function, it is just x plus 2 there. So our below function is just x plus 2 there. So we have x plus 2 there. So now this is equivalent to, I'm gonna have negative x squared plus 14x plus 49 plus 25 minus x minus 2. Distributing this negative, I'm going to have negative x squared minus 14x minus 49 plus 25 minus x minus 2. Let us group our like terms. I'm going to have negative x squared. I'm also going to have minus 15x. So this one is just minus 49, which is minus 49 plus 25, which is what? Minus 24 minus 2. So that's negative x squared minus 15x minus 26. So that's what you have. That's what you have there. All right, that's what you have. So minus x squared minus 15x minus 26. That's what you have. Okay, that's what you have. Now we want to find, like the question says, we want to find the value of what? The value of x, which will give you the length of Mn as a maximum. So we need to think about minima and maxima there. We need to think about minima and maxima. Let us recap a bit. So if you have your function of this form, this is your maximum point, your maxima. This one, it is your minima. You can you can find maxima and minima by equating your function to 0, the derivative of the function to 0. But now, how do we define a maxima? Maxima, it is the highest point that the function can attain. Minima, it is the lowest point that the function can attain. How can we do that? So this is L of x. So we're gonna say L prime of x. We need to find the derivative of this. So it is minus 2x minus 15. Minus 2x minus 15. Now, at maximum L prime of x, it is 0. So now we have 0 equivalent to negative 2x minus 15. We take this 15 that side, so we can have positive 15, we have negative 2x. We divide both sides by 2, we divide both sides by 2. So your x will be negative 15 over 2 there. So that's the value of x for which this function, or for which this Mn will have a maximum length. I hope you have enjoyed this video, and please make sure that you redo this question. Make sure you write all the solutions, make sure you check the mark allocation, and make sure that you choose methods which will work for you. Methods which are easier to understand, because I have provided various ways on how to solve some problems here. I hope this video was helpful. Thank you so much. See you on the next one.